All right, this is lesson 7.3. This is quadratic connections part 2. So our opening picture here just reminds us of the different things that we were looking at. In module 6, we went from this form and then used the grid to multiply out to get this form. And we started the last lesson looking about how we do this actually in reverse. The things with the parentheses here, the things that are multiplied together, these are called factors. So things that are multiplied together to give us something bigger, these are called factors. And we can normally identify them by the parentheses, normally with the X here as well. Now, the thing that we noticed last lesson, which was really important, is if we actually graph these equations and actually look at the X-intercepts, not easy to see on this picture here, but an intercept of 1 and an intercept of 3. If we choose the opposite sign there, so instead of positive 3, I put negative 3. And instead of positive 1, I put negative 1, then I can actually create the factors by using this expanded form. Now, our first question just reminds us about a little bit of vocabulary, and we have to identify the parts that are shown here. And we do have a word bank here to choose from as well. Now, number 1 is probably more of an Algebra 2 question. So it's the part that goes through the middle of the graph. So it makes the graph symmetrical. So for that reason, it's called the axis of symmetry. Number 2 is the lowest point on the graph. So the word for that is vertex. And for number 3, we see that there's two, well, I'm calling them x-intercepts because that's the first word that I think of. But also it says on here, some parts of the graph may have multiple names. So this is one of the key ones where there's lots of words that all mean the same here. So as well as x-intercepts, we could also use the word zeros, and they've put zeros as a function here. Also the word roots, and also solutions. So it's important if they ask you for any of those words that you know that really what you're looking for is the x-intercept. So last lesson, what we looked at, like I said, is we looked at what the intercepts were. And if we just write them down, so I can see that this one is 4, and I can see that this one is negative 5. If you're not sure, you can actually just click on the graph, and it will actually tell you exactly what they are. There we go, that's a good start. So writing this in factored form, then I just do the opposite of what it says. So instead of positive 4 there, I'm going to put negative 4. Once again, I'm using parentheses and an X here. So instead of negative 5, I can put positive 5. And a student did ask the last lesson as well, does it matter which order you put these two things? And the answer is no. Using the commutative rule, you can write those either way around and it would still be correct. Just a little reminder of some of the different notations we're going to use. So it says enter this equation. So let me go ahead and enter that. 2x plus 1, x minus 3. And you can see that nice U shape again there because we've got an x times an x here, which will give us an x squared. So I can click on my roots or zeros, whatever you want to call them, zeros it says here. So it said 0.5, and this one said 3. And we'll go ahead and submit. And this time it doesn't seem to have done anything, which is a little bit strange. Sometimes, though, it will ask you to put these as fractions. So I think if I remember on the last slide, yeah, to convert a decimal to a fraction, you can just type in the decimal, hit the fraction button, and it will actually convert it for you. So instead of 0.5, let me go back, see if it prefers 1/2 as an answer. And actually, it's put 0.5 at the end here. I'm not quite sure what's happening there. That's definitely, oh, I wasn't looking carefully enough. It said negative 0.5. That would be the reason. So minus 1/2, and then that should be a better answer to that question. Or it might be looking for negative 0.5. I'm not quite sure because I didn't actually write this. But we're going to say that that is good for this point. Okay, we already used that part, so let's move on to the next one. So another equation, 4x plus 3 and x minus 3. You can see part of the U shape starting to form there. This time I better pay a little bit more attention. So at negative 0.75. And the other one was 3. And it says that's okay, but it says what is the equivalent fraction of negative 0.75? So if we're not sure, we can just go ahead, like we did in the last one, type that in, and then we can get negative 3/4 for that. And that might have been one that you knew anyway. So negative 3/4, and let's see if it prefers that. Actually, it doesn't seem to do anything when you do type that in, but hey. Normally when we're doing these questions, although the Desmos gives us the decimal, we're actually more interested in the fraction, and we'll talk about why that is in a little bit. All right, next one, 2x plus 7 and x minus 3. And we'll click on the numbers. negative 3.5 and 3. So negative 3.5 and 3. And if we do want that as a fraction, we can just do that same thing again. Negative 3.5, click, and it'll give you negative 7 over 2. And we could type that in if we need to, but we're going to leave it like that. So we're just doing decimals by the looks of it. I didn't realize, it doesn't specifically say, I don't think, unless I misread the question by reading quickly. Now, there are a few that you should recognize as well, because they won't change. 0.333 is going to give us 1/3, if it's repeating, that is. And 0.666, which actually rounds to 0.667, is actually 2/3. And the reason you would want to know that is, if we type 0.333 in, it actually thinks it's 333 over 1,000. The problem is the threes actually just keep going on forever and ever and ever. Oh, look what happens actually if you type in enough threes. It will actually tell you exactly what it is. So that might be useful to know as well. But the 0.667, it'll give you 667 over 1,000, which really is not what we want. We want the sixes repeated. Aha. And it will actually tell you it's 2/3. But those are two that you might just want to make sure you're aware of, rather than having to think about it too much. Now, we have a list of all the questions and all the answers here, and there is some connections here. Clearly, the factors and the roots, again, of zeros are the same. So we got negative 3, do the opposite, positive 3. Negative 3, do the opposite, positive 3. Look what happens on this one, though. So instead of positive 1, I have negative 1. But also notice this time we have a fraction. And look what we're dividing by. We're dividing by this number at the start as well. So I did the opposite of positive 1, which is negative 1. And remember, 2x actually means times by 2. So the opposite of timesing by 2 is to divide by 2. So very similar rule for this one. So for this one, instead of positive 3, I've got negative 3. Instead of timesing by 4, divide by 4. Instead of positive 7, negative 7. Instead of timesing by 2, negative 2. So that's how we're actually going to solve the problems where we don't get whole numbers. Last lesson, we only had whole numbers. If we end up with decimals, we want to change them into fractions. Negative 0.5 is not going to help me. But negative 1/2 means I can actually figure out what these are then. And I can do these in reverse as well. So if I see negative 1, I know my factor is positive 1. And instead of dividing by 2, I know I can times by 2, which would give me that 2x. And there's a few extra questions we could practice on if necessary. So 3x plus 5 would actually give us then negative 5 over 3. This would give us positive 3 over 2, positive 5 over 2, positive 1 over 2, and negative b over a. And we could do the other ones as well. Positive 3. Notice when it's just x, we just do the opposite. Technically, you could divide by 1, but it wouldn't do anything. Positive 3 divided by 1, positive 3. Negative 4 divided by 5, negative 3 divided by 2, positive 3 divided by 4, and positive e divided by d. So we're just using those opposites when we want to switch between factors and zeros. So if we're actually given the zeros and it asks us for the question, we're just going to go ahead and do the opposite. So where I see 1, I'm putting in negative 1. When I see positive 2/3, I'm technically putting negative 2/3, but I want to move that bottom number up to the front. So instead of putting the 3 on the bottom, I'm going to bring the 3 to the front like so. And we can check that that's correct. So with 4/5, I really want to put x minus 4 over 5, but that bottom number, I'm just going to bring to the front. So I'm doing the opposite, divided by 5, which is to multiply by 5. And instead of negative 2, I can just go ahead and fill that one in as positive 2. Doing the same with the other ones, I see this as negative, so x plus 4 over 5, but bring the 5 to the front. And do the same for the other one. This would be positive, making it negative. So x minus 4, whoops, I got my parentheses the wrong way around. And it would be divided by 5, so bring the 5 to the front, and we should be good there as well. Instead of negative 3/5, I want to put positive 3/5, but bring that 5 up to the top. So instead of dividing, we would multiply by 5. And for 4/9, we would do x plus 4/9, bring the 9 to the front, so 9x plus 4. There we go. And if necessary, if you wanted to check this, you could type this into Desmos, remember, and then just click on the decimals, the zeros, and just make sure that they are actually true for that. Now, a little bit, put all this together. Once you've asked it to factor, like you did for homework last lesson, we should try that question. That's normally what they're going to ask us to do. So you type the equation into Desmos, you look at the x-intercepts, change them to fractions, that's if they're not whole numbers, and then you can work out the factors. So let's take a look at the question. So 8x squared plus 2x minus 3. We've got multiple choice answers. I've already gone ahead and typed this in just to speed things up a little bit. So I got negative 0.75. And I also had 0.5, which is clearly going to be 1/2, but we'll just make sure. So I got negative 3/4 and 1/2. So as I'm actually writing the answer down then, I'm doing the opposites for the factors. So instead of 3/4, I'm doing, instead of negative 3/4, I'm going to do positive 3/4. I'm going to bring that 4 up to the front. And I'm going to do the same for this one. Instead of 1/2, I'm going to do negative 1/2. But I'm going to bring that 2 up to the front. Now notice what happens as I change my answer as well. It might not have been immediately obvious, or perhaps not for me with my sense of color. These are actually the same answer. As I switch this on, that's a great way to check your answer as you're working through a question. Write down exactly what those intercepts are, and then once you've got your fractions, write out your factors in the same question, and then check what we got. So 4x plus 3, 2x minus 1. It's got it the other way around, but there's 4x plus 3 and there's 2x minus 1. And we can actually type in that question there as well. And I think that's it for this, actually. Let's see what else we've got. Oh, specific properties. That's it for the factoring side. Sometimes, though, you're asked for what are the x-intercepts or how many x-intercepts there are. So let's have a quick try on that type of question as well. Identify each function that has an x-intercept of negative 4. If you don't know, then what you have to do is you just have to graph these. Now, to save us time again, I've actually gone ahead and typed each one of these in, but I've switched it off. So if I switch this on, I'm looking for what does it go through negative 4 on the x-axis? So no, but it goes through negative 4 on the y-axis, but I'm not really interested in that. For the next one, there you go. That second one certainly goes through negative 4. Nope, it goes through positive 4, so that's no good for this one. That one certainly goes through positive. Whoops, I forgot to switch that line off. There you go. That one goes through negative 4. No, it goes through positive 4, but we're not interested in that. And this one goes through negative 4. Now, the reason some of these go through 4 is they're hoping that you're going to do the opposite, but it doesn't say factor. It just says x-intercept. So you're literally just looking at when does it go through negative 4. So I just want to make sure I don't forget which ones it was. It was that one. I'm trying to see if it was that one or not. Yes, those were the 3, and you can actually see that it goes through. Oh, that one doesn't actually. Whoops. There we go. You can see that those all go through negative 4. So it would be your second, fourth, and sixth options. And unfortunately for questions like this one, you have to get all of them correct. And if you actually miss one, then you don't actually get the correct answer. So that can be a little tough, actually. And the other question, which of these functions have exactly 2 different zeros? So that means there's 2 x-intercepts. They could easily ask 1 x-intercept, and they could easily ask 0 x-intercepts. Once again, I got them typed in just to speed things up a little bit. So for this one, you can see that it only goes through 1. This actually looks like a straight, kind of looks like a straight line. Oh, there we go. It's a good job I did zoom out. We got that U shape. So yeah, this one's good. This one goes through 2 places. And this one goes through 2 places on the x-axis. So the first 2 are both good. This is just a straight line. So no, this only goes through once. Notice there's no squared on this. That's why we don't get the U shape this time. And for this one here, it just touches at 1 point this time. So although it's squared, it doesn't pass through the axis 2 times. So the last one, this one does go through 2. We did talk about last lesson, if you have a negative x squared, it would actually draw the graph upside down, and you can see that on this picture here. So I believe it was those ones there, and then we could easily go back and select those as well. That concludes the video for this lesson. And yeah, there's more videos as well available on the YouTube channel if you need to go back and watch those as well.